Welcome guys, I'm DrAvitech, and in this video we're going to be tracing how to sketch a graph or how to sketch graphs. I know you've been waiting for this for a very long time. So before we get started, remember to hit the subscribe button, like this video and share it across to your classmates. Then you could watch this video at the highest resolution by changing the quality of the video in your settings. Also, make sure that you set your screen to full screen. Now, before we get started, if this channel has been of help to you in one way or the other, please make a donation, as a donation would make me be able to make more videos and also create much more valuable content for you. So let's see. The first thing I want to start with is horizontal and vertical lines. Now, what we want to do is, in this video, you can actually skip to any part you want. So you could skip to maybe trigonometric or piecewise. So I'm going to be doing a whole lot, focusing more on piecewise, because that's why we're here. We're here for Fourier series. So we want to know how to graph piecewise functions. Now, the first thing you want to do is this. The graphs would always have x and y axes. So always x and y axes. Now, let us start with vertical lines first. Let's start with the vertical lines. So a vertical line is like a wall. It's like a wall. So it only has this. Let me kind of draw this guy. So this is our x, this is our y. That's what we have. That's x and that's y. Now, if we have a vertical line, here's a vertical line. X equal to 4 is a vertical line, because if you should, let me say, on your x-axis, you put 1, 2, 3, 4. If s is equal to 4 and you're asked to just draw this, nobody will ask you, because that's almost useless. So this is 4. That means you have something like this, because on this very line, s is equal to 4 on this very line. You were not given any coordinate of y. So s equal to 4 is just going to be on this line. I hope you're getting this, because this is just an introduction. So though nobody will ask you to draw a vertical line, but this is it. So if you're asked to sketch s equal to 4, this is just it. Now, if you notice, there's never a line that you're going to be sketching that's going to be s equal to 4. It's always y equals something. It's always f of s equals something. So that's why I said your vertical lines, no one might ask you. But I just decided to, introduce that, so we see how to go about it. So s equal to 4, that's how you draw it. S equal to 3 would also be a vertical line here. S equal to 2 would be a vertical line, and just like that. So vertical lines are only having the x value. So there's no such thing as a y value. So yeah, this is it. That is for x. So these are vertical lines. And in all of our questions, we won't be doing them, because there's never a time we use x. We always use y equal to something. Our graphs are always in terms of y or in terms of f of x. Okay, now how about horizontal lines? Now, when you come to horizontal lines, these ones deal with the y. So if I have something like this, I really do hope that my graph will be straight today, because this line is not looking straight. So if I have something like this, and I'm asked to draw, let me say, y equal 4 also. So this is y and this is x. So if I should draw y equal to 4, let me say I put my 4 right here. Y equal to 4 means there's going to be a line at 4. So on every point on this line, y is equal to 4. On every point in this line. We're not given any value for x, so y is equal to 4. Now take note that this y equal to 4 also means that f of s is equal to 4. Just that we aren't given any value of x. So this one has no x input, this one has no y input. When you are dealing with the analytic description of periods, or periodic function, sorry, you're only dealing with the slanted lines or the horizontal lines. You don't deal with the vertical lines, because the vertical lines do not have y. Because whenever you are describing your function, it's always in terms of y or f of x. So since there's no y here, it means it's just kind of useless. That's just it. Okay, I'm kind of thinking of something. Did I say something wrong in a particular video? I'm kind of remembering something. So please take notes. If for any reason you notice anything, any mistake, you let me know. So this is what we have about horizontal and vertical lines. They're really, really not difficult. They're not hard to draw. They're very, very easy. Okay, so let's proceed to the next one, linear graphs. And that's where we then get started with every single thing that will be problematic. So let's get started with linear graphs. Now, the first thing we want to know is a linear graph is always in the term of y equal mx plus c. Some persons might choose to say y equal mx plus b. It's still the same. There's no difference. Now, I don't really want to talk much about this. The only thing I want to say is m is your slope or your gradient, then c is the y-intercept. That is what those two things are. Basically, if I want to draw a graph, I kind of put this at the back of my mind whenever I'm doing linear graphs. That if I have my graph like this, and the line passes through like this, I call this line x. That is just x. So this is x. So this line here, let me say this is line AB. This will be x passing through the origin. That's line x. Then, if I have this one here, that's not perfectly passing where I want it to pass. So hold on, let me see if I can just draw this again. So yeah, let me kind of draw it like that. So this one is going to be minus x. Now, notice how this very one is like this. This is positive x, while this is negative x. These informations are very, very important, please. So that's for x, and this for what? Negative x. So what I normally say is, if the slope, because this is mx, so if the slope is positive, it looks like a forward slash. Am I? Yeah, I kind of say that's a forward. Is that a forward slash? Then this is a backward slash. So one of them, this is a forward slash, this is a backward slash. Well, it might not really matter because you can actually plot graphs without knowing this. So yeah, there's another way to do this. So let's start with the first question here that I have. We're going to plot y equal 4x plus 5. Yeah, y equal 4x plus 5. Now, if I want to plot this very graph, there are two things I do. I look for the x and y intercept because every single line must cut the x and the y-axis at some point. It's a must. It must cut the x and the y-axis at some point. So let us find those points for this guy. Now, how do we do this? We're going to say, find the value of x when y is 0, and then find the value of y when x is 0. To start with, finding the y-intercept is not hard because the y-intercept is your plus c. So the y-intercept here is what? 5. So it means that this graph would cut the y-axis at 5. Let me say that again, please. Let me say that again. I said if you want to plot a graph, you need two things for linear graphs. You need the intercept. That's what I use. You could decide to use any other points, yes. But I just prefer to just use the x and the y-intercepts. In this case, when we get to piecewise functions, I'll tell you how I do that. So in this case, I'll just pick my x and my y-intercept. So first of all, I'm going to say that, to get my y-intercept, that's easy because in the formula for the equation of a line, y equal mx plus c, c is the y-intercept. So if you compare it to this, you see that 5 is the y-intercept. I'm going to put y equal to 5. So that one is easy to get. Now, how do we get the value of x? We can get the value of x if we say y should be 0. That is, if we should remove this part, we can solve for x. Yeah, we can. So I'm going to say that when y is equal to 0, this means from the equation, 0 is equal 4x plus 5. Then I can say that this is minus 4x equal to 5. That is, kind of subtract 4x from both sides, or take 4x to this other side. So that's minus 4x. So x will then become, divide both sides by minus 4, so that's minus 5 over 4. Now this is what we have. This is what we have. So I'm going to plot my graph now. I'm going to say I've got something like this. So this is my x and this is my y. All right. So I'm going to put 5 somewhere here. I'm going to put 5 somewhere here because I have y equal to 5. Then x is minus 5 over 4. I hope you know that this minus 5 over 4 means minus 1.25. So you can use a calculator for this, minus 1.25. So right now, let me say it's going to be, this is 1, this minus 1, this minus 2. So it's going to be somewhere here. So minus 5 over 4. Yeah, somewhere here. So I have this and I have this. What do I do next? I pick up my ruler and I kind of join them together. I kind of hope this will be perfect. Wait, first of all, let me join this. It's not looking fine. Okay, let me put it here. So then I extend this. And this is just the line y equal 4x plus 5. That's just it. So you've been able to sketch that linear graph. That's just what you have to do. And this is the answer for this very one. That's how you sketch that very graph. Very easy. Let's take a look at the next linear graph. Let's take a look at the next one. So the next one, number 2. Please, it's not kind of straight, but use a ruler for that. Use a ruler. So let's see. The next one, let's see, this one is easy. So y is equal 2x minus 8. Y is equal to x minus. Please take note. If you notice, I want to use different methods so you understand all of the methods available. So what I'm doing, this is just using intercepts to plot my graph. When I get to piecewise function, we're going to just find our points instead. So let's get started. First of all, what do you think will be the y-intercept here? When you look at this line, the y-intercept will become minus 8. So you have y is equal to minus 8. Very easy, right? Okay, now let's find the x-intercept. So to find the x-intercept, we're going to say, okay, let y be 0. Now here's the thing. Here's the thing about intercept. When you're finding intercept, one of the values have to be 0. So currently, this part where we've said y is equal to minus 8, this means x was 0. That's the meaning. Because if we should put 0 here, 2 times 0 is 0. So you have just minus 8 remaining. So whenever you're dealing with intercept, if you find one, it means the other one is 0. Or if you say one of them is 0, it means you're going to find the other one. Currently, if you look at this minus 5 here, sorry, this 5 here, y is 5. What will be the value of x on this very line? Value of x here is 0. So that's how it works. So currently, let's say our y is what? Our y is 0. So this will be 0 equal 2x minus 8. So take this 2x to the other side. So this is minus 2x equal to minus 8. Then to get x, divide both sides by minus 2. So this is minus 8 over minus 2. So x is equal to 4. So we've been able to find out 2 points. Let us plot our graph. So we know that y is minus 8. And minus 8 is going to be somewhere here on the y-axis because this is y and this is x. So we know that y is minus 8. So this, from this part, let me put 0. From this path upwards is positive. This path downwards is negative. So negative 8 is going to be somewhere here. Let me just put it here. Negative 8. Then x equal to 4. This is positive x. This is negative x. So let me put my 4 right here. That's my 4. Then I'm going to say, I'm going to connect them together. So this point and this point will be connected together. So first of all, let me use a ruler to just join them. Then I can extend it if I wish. Yeah. Because it continues just like that. So that's what it becomes. And with this, I've been able to plot y equal 2x minus 8. And that's how you do this one. I know it's not kind of straight, but you kind of get the picture. So So this is what we kind of have to do about sketching y equal 2x minus 8. Remember to hit the subscribe button, like this video, and share it across to your classmates. Let's go to the third question on linear graphs. I think I wrote lots of questions here. Lots of questions. So yeah, I'm going to wipe this out. The third one on the linear, we have 2y plus 7x take away 3 equal to 0. Now that's looking a lot more confusing because you have something looking different, but actually it is not. And as always, remember that the first thing we do is to find our y-intercept. But if y is equal to mx plus c, it means you must also make y the subject. It means you should also make y the subject. But let's not be doing that in this case, since y is not already the subject. So it's going to be a tedious work for us to do. So let's not do that. It's not really tedious. Making sure the formula is actually easy. But I don't want to follow that road. Let's do something else. So if I want to find the y-intercept, all I have to do is to eliminate x. So this means I have 2y minus 3 equal to 0. So 2y is equal to 3. And then y is going to be 3 over 2. You see that, right? So right now, I've gotten a value of y. It's better, I just prefer it. So the next one, let me write the equation again. 2y plus 7x minus 3 equal to 0. So how would I find x? Let this one be 0, so this one is gone. So I have 7x equal to 3. Then s will then become 3 over 7. When I divide both sides by 7, I'm going to get 3 over 7. So currently, I've been able to get my intercept. So let me plot my graph. Even though they're looking like fractions, but you would get the picture when the time comes for you to plot it. The only thing you need to always remember is their decimal values. So this would be 0.4 something. That's what it's going to become. Just like that, 0.4 something. Then this one is going to exactly be 1.5. So let me plot my graph. Okay, so that's looking kind of straight in my eyes. So this is 0, this is y, and this is x. Then I have my y at 1.5, so let me place 1.5 here. It is sketch, remember, shouldn't be perfect. But if I have a square grid or a grid paper, I can be able to plot this perfectly. Then 3 over 7 is 0.4, so it's going to be between 0 and 1. And it's going to be closer to 0 because it's not up to 0.5, which is half of this distance between 0 and 1. So let me put my 3 over 7 somewhere here. And then I have it. That's what I have. So I'm going to plot that guy. I'm going to draw them together. This is what I have. Yeah, together. Then just continue this line like this. And that's it. So I've been able to sketch that very guy. That was easy, wasn't it? So it's easy. So it's not difficult for us to sketch. So let's see what this next one is going to be. Let's see. This will be the last. This will be the last on linear graph. So that's this number 3. This number 4. Y is equal 1 minus 4x. Now, do you know that you can actually tell if this is, would this graph have a negative or a positive slope? This graph would have a negative slope, looking at it, because it looks like a backward flash. Am I really getting it correctly? I call this one forward slash. And I call this one backward slash. So, if you have a graph, a linear graph, whose line is like this, it's going to have a positive slope. This is a positive slope. And if you have a line if you have a graph whose line is like this very one, this is a negative slope. But I don't think it's really that useful when we're dealing with Fourier or plotting our graph. Not really that useful. Just that some ideas are just important. So when you see a particular graph, you can be able to tell that, oh, that's how it's going to look. it cannot look like this, but this is going to look, so it's very, very important. This is more discussed in coordinate geometry. When I deal with analytic geometry, that is where these slopes and all of the rest are perfectly discussed. So I have y equal 1 minus 4x. 1 minus 4x. So let us find our y-intercept. It's not difficult in this case because y is already the subject. So what's our y-intercept? Y-intercept is just 1. So it's not difficult. So our y is equal to 1. So that one is actually the easiest. Then the next thing is let us find our x. So we know that y is equal 1 minus 4x. So if this one goes, if that goes, this will then become 0 equal 1 minus 4x. So take the 4x to this other side. So that's 4x equal to 1. Then divide both sides by 4. So x will then become 1 over 4. And the value of this is 0.25. So that's what I have. That's what I have. Okay, so let us plot this graph. Now looking at this is minus 4x. So the graph will be looking like this one also. To be a backward slash. So this is 0, this is y, and this is x. So let us put in our y equal to 1. So this is y equal to 1 here. Then x is 0.25. So between 0 and 1, divide it into 4 places. That's the meaning of this 1 over 4. So divide it into 4 places and pick one part. So let me put it here. Yeah, let this one become 1 over 4. It's a sketch, please. It must not be perfect. So this is all we have. This is all we have. So I'm going to connect them together first and then proceed. Assuming I have a ruler, I can just connect them once. So this is, let me write y equal 1 minus 4x, then 2y plus 7x minus 3 equals to 0. So this is actually much more easy to understand. Let us go to quadratics. Let's go to quadratics. Remember to hit the subscribe button, like this video, and share it across to your course mates. So one important thing to note about this quadratic is the graph can come in two ways. So your parabola can either be opening upwards or be opening downwards. Please take note that your graph will look like a U. So it's opening upwards, if A is greater than 0. And then it's going to open downwards if A is less than 0. That's the first thing you need to know first. When you're given a quadratic graph, the value of A is the number in front of S squared. A is that number in front of S squared. So if A is greater than 0, it's going to look like a U. And then if A is less than 0, it's going to look like an N. Yep, that's what it's going to look like. Okay. Now, what's the next thing? There are two ways to go about this. There are two ways to go about plotting quadratic graphs. Either you represent them as a vertex, so there's something called vertex form, or you kind of use a midpoint theorem to solve it if you can find the solution of the quadratic. So let me explain what I mean. So here's the first equation. Y is equal S squared plus 4x, let me say plus 5x plus 4. Okay, yeah, so that's the first one. Now, right now, let me say I can solve this quadratic. Let me say I can solve it. Find two numbers you multiply to give you 4. Add the same numbers to get 5. The numbers are 4 and 1. The numbers are 4 and 1. So if you solve this quadratic, so if you say let s squared plus 5x plus 4 equal to 0. What am I trying to do here? I'm trying to find the x-intercept. Because now I am saying, let this y be 0. So let me eliminate the y. So let the y be 0. If I solve for this, it means I'm going to be finding the x-intercept. So to find the x-intercept means to solve the quadratic equation. So now I said to solve this equation, we'll find two numbers with times to give us 4. Add the same numbers to get 5. And I said the numbers are 4 and 1. Because 4 times 1 is 4. 4 plus 1 is 5. So to solve this quadratic, s would equal to minus 4 or minus 1. Please take note, I'm not really dealing with how to solve quadratic here. So I believe we can all solve quadratics, and That is why I just went straight forward to getting the final result of our answer. So that's not really a difficult one. Please, it's not difficult. It's not difficult. Okay. Now, since we have it that s is equal -4 or -1, the only thing we've been able to get here, this information, is only going to help us get our x-intercept. But this will not help us find, it's not going to help us find our vertex. Because in this case, our vertex is very, very important. So it's not going to help us find our vertex. Now, what are we going to do? What are we going to do in this case? Now, let's use our midpoint theorem to find our vertex. Let's use our midpoint to get our vertex. So first of all, our x, should I say x vertex? Okay, anyone. So x vertex will become this plus this divided by 2. Let me explain, please. I think I should give much more explanation to what vertex means. Now you can see these very two graphs here. This point right here, this point right here, this point right here is our vertex. So the point also determines if we have a minimum or a maximum value. But please take note, there's a separate video for this. There's a separate video about minimum and maximum value and how to get it through vertex form. Now, this very point you see here is like the center of the graph. Because if you should get a knife, if you should get a knife and you split this into two, this part and this part will be equal. So we kind of call this the vertex. It's either the maximum or the minimum point of the graph. Is that the point where the graph will start falling or start going up? Here, this is the point where it starts going up, while here, this is the point it starts coming down. So this very vertex is very important. Now, since you know, listen up, since you know what this point is, -1, and you know what this point is, -4, to get this one in the middle, this very point here, what you have to say is this plus this over 2, just like when we're doing midpoint. So we're going to say -4 minus 1 over 2. That's what we're going to do. -4 minus 1 over 2. So this will become -5 over 2. And this will become our x mid, or the point at which we're going to get our vertex value for x. Now, to get the value for y, what we do is, in this very equation here, s squared plus 5s plus 4, anywhere we see x in this equation, we're going to put -5 over 4. So we have s squared plus 5x plus 4. So this will become, x is -5 over 4, so this is -5 over 4 squared plus 5 into -5 over 4 and then plus 4. Right now, -5 squared is 25, so this is 25 over 4 plus times minus is minus. 5 times 5 is 25 over 4 and then plus 4. There's a mistake, please. 4 squared is 16, so this ought to be 16. I was supposed to say 4 squared. I only said -5 squared. I was also supposed to say 4 squared. So that was a mistake. Okay. So right now, let's take LCM. But before then, if this is the over 16, if this guy here is over 16, I can also make this to be over 16. So this is 25 over 16 minus, how do I make this over 16? I'll times by 4. So 25 times 4 is 100. 4 times 4 is 16. Plus, how do I make 4 to become over 16? I can say that, that's a tedious one. But it's not really tedious. 64 over 16. 64 over 16 is the same thing as 4. Please take notes. The method I've just done here is still the same as you taking your LCM and doing what you want to do. What I'm just doing is I'm trying my best to make sure that every single thing have the same denominator. It's still the same, please. Do not stress yourself, or should I say trigger yourself about it. So right now, let's proceed. Now, since they all have the same denominators, it means I can just evaluate the numerator. 25 minus 100 plus 64. I can just do that. So 25 minus 100 is 75. So 75 plus 64. Let me just say 75 minus 64. So this would just be 11. So the answer for this would then become minus 11 over 16. Yeah, you can actually check if that's correct. So it's minus 11 over 16. That's weird. Okay, so we've been able to get all values, the values that we need. Please take note, when it gets to a piecewise function, I won't really be doing this much. I won't really be doing this much. So let's see. Let's see what this one would be. Okay, before I sketch this, let me show you something. Let me show you something. Oh God, I kind of hate it when my graph is not looking like what I want. Okay, I think I'm going to remove this X line first. Yeah, let's draw this. Okay, anyone. It's just a sketch, so let's just see how we can best understand what's going on. I was not supposed to draw that guy. Okay, now one of this is x squared. One of this is minus x squared. Now this one you see here is x squared. This one here is minus s squared. Okay, because I need to first of all explain these two. Now, why is it like this? I told you that if this is greater than 0, if a is greater than 0, if we check here, a is a number in front of s squared. So that number in front of s squared here is 1, and 1 is greater than 0, so it's going to look like a u. Now, if the number is minus 1 is less than 0, so it's going to look like an n. So that's the first thing you need to notice. Now, if I have a graph like this, s squared, it means my graph is going to be looking like this. It means my graph is going to be looking like this. Now, there's something called translation or transformation. So I don't want to be, transformation. I don't want to be doing that. But this is your, we call this the base graph. Yeah, we call this the graph that we can follow this graph and then we move to this. Yeah, we take this graph and then we move to this. So let me draw this graph now. But it's important to know what x squared looks like and what minus s squared looks like. So let's then draw that graph. Would that part be enough? Okay, I kind of have to manage it. Okay. So the first thing is, I know that since this is s squared and this is s squared, my graph will be looking like a u. Next, my x is at minus 4 and minus 1. So I'm going to put this here, minus 4, minus 1, and that's 0. So already I know that my graph must pass through these points like this. Yep, my graph must pass through that point, just like that, Then, my x is at minus 5 over 2. So it means I'm going to be putting minus this point you see here. This is the vertex. So you have minus 5 over 2 here. Then on the x, this is minus 11 over 6. And that's just it. I've plotted the graph. Let me say that again, or let me do that part again. Let me just do it again. The first thing you want to do is to identify your x-intercept, which is at minus 4 and minus 1. Then you kind of plot a graph. It's a sketch. Please. If I were to be graphing this actually using a normal graph, I first of all have to identify my intercept, identify my vertex before I then draw this. That was what I was supposed to, that's the right procedure. So I'm supposed to put minus 4, minus 1, and then put this point so that the curve will pass the 3 points. So to pass minus 4, pass this vertex here, which is at minus 5 over 2, comma, minus 11 over 16, and then also pass minus 1. It's very important you know this. That's just what the graph is going to look like. Now, one important thing you want to do, or you want to know here is, there's something I always use when plotting graphs. So there's an app, it's called Desmos. So take note that this is not an advert or anything. It's not a promotion. So Desmos would help you graph your functions, and you're going to know the important parts of your graph or important information about your graph, what the x-intercept is, what the minimum value is. So that's what I use most times. So if I just want to quickly graph something or I need to visualize it, I'll just come here, put in the function, and know what I'm doing. So that's what I just use most times. That's what I use most times. So if I have the time, I might actually attach the image of Desmos of about this very graph on this video. But this is just what it is. Let's move on to the next one. Next one on quadratics. Y equal s squared plus 3x. Okay. Now, y equal s squared plus 3x, that's actually an easy one to solve it. It's actually an easy one. So if you want to solve this, all you have to say is your y should not be 0. This is 0 equal s squared plus 3x. Now, if you notice, this would then mean that 0 is equal, what's common here is x. So s squared over x is x, plus 3x over s is 3. Now, at this point, any of these two could be 0. So s is equal to 0, or s plus 3 is equal to 0. So that's how you do that. So s is equal to 0, or if the plus 3 goes well, it's going to become minus 3. So you've been able to get your x value. So next, let's get our x vertex. So the value of x at the vertex. I'm going to say this plus this, so that's 0 minus 3 over 2. If you notice, the plus minus is minus. So I normally take that out. So 0 minus 3 over 2. This means I'm going to be having minus 3 over 2, which is minus 1.5, but let's leave it like that. Now the y value, the yv, first of all, remember that y is s squared plus 3x. So s squared plus 3x. Anywhere I see x, I'm going to be putting minus 3 over 2. So minus 3 over 2 all squared plus 3 into minus 3 over 2. So if I should square this, I'm going to be getting 9 over 4, and then plus times minus is minus, 3 times 3 is 9, all over 2. Yeah. Now, in this case, let me just use the LCM that we already know. So put LCM here over 4. So 4 divided by 4 is 1. 1 times 9 is 9. Minus 4 divided by 2 is 2. 2 times 9 is 18. So 9 minus 18 is minus 9 over 4. This is what we have. I think this thing is making too much noise. So that's what we're going to be having. So right now, let us plot our graph. Again, this is s squared, so it's going to look like a u. So I'm going to be having something like this. So I have 0 and minus 3. So this is x at 0, and let me put the minus 3 somewhere far. Minus 3. Then next, my vertex, okay, let me write it in terms of our vertex is the x will come first, minus 3 over 2, comma, minus 9 over 4. So that's our vertex. So right now, let us locate this point. So we know that our x is minus 3 over 2, which is going to be in between minus 3 and 0. So it's in between this. Then this is minus 9 over 4. So let me just sketch. Let me put it here. Let me just put it somewhere there. Okay. Like I said, since this is a sketch, I can just draw my u and then put this minus 9 over 4 anywhere. But I just kind of know that that's my vertex, so I have to be very careful about it. Let me put this guy. Okay. This is minus 9 over 4, and this was minus 3 over 2. Yup, and this is how it's going to look. Yep. Those are the graphs. Even though this graph is going to be looking more U-ish and less V-ish. It's looking like a V. It's supposed to look more U, more U-ish, more parabolic, or more parabolic. So that's how it's supposed to be looking at that very point. But this is how your graph will basically be. You You can start. This is actually very easy to sketch. It's very, very easy. Now, please take note. This is looking very, very easy. It's easy. So let's proceed. It is easy. It's easy. So I'm going to wipe that guy off. Before then, let me do number 3 in this location. Number 3. So y is equal 4 minus s squared. So that's what we have. Y is equal 4 minus x squared. How would I plot that guy? Yeah, it's still easy. It's still just the same. So I'm going to say, let this one be 0. Please take note. I am actually doing all of this because I know that they can be solved. That very one can be solved. That is, you can solve for the value of x and have an answer. There are some of them right here on this paper. They can't actually have an answer that you know. Yeah, they can't have an answer that you know. So what we then have to resort to is either calculus or vertex form. But I will just use vertex form. I don't want to discuss calculus here. I don't want to introduce calculus. So this is what we have. So we have y equal 4 minus s squared. So this will be 0 equal 4 minus s squared. And what would I do next? I'll use difference of squares if I want to. Yeah, you can actually use difference of squares. Or better still, let me just use square property to solve this. So minus s squared will come here. So that's s squared equal to 4. So s then become the square root of this. That's the square root of 4. Then put a plus or a minus. So s will then become plus or minus 2. So that's your answer. S is equal plus 2 or minus 2. So that's just it. That's just what it's going to be. Now, what is our x mid? X mid or x vertex. So I'm going to say this plus this. So that's 2 minus 2 over 2. So that will be 0. Because 2 minus 2 is 0. 0 over 2 is 0. So that's what we have. Then our yv, the vertex part for y, write your equation. Our equation is 4 minus s squared. So anywhere we see x, we're going to call it 0. So this is 4 minus 0 squared, which is just 4. So that means our vertex is located at 0, 4. That's our vertex. It's located at 0, 4. So this is what we have. And with this, we can plot our graph. With that, we can plot our graph. Where would I wipe? Okay, anyway, let me wipe this guy. Remember to hit the subscribe button, like this video, and share it across to your classmates. Now, all of these ideas would be very, very important when we get to piecewise function. So, let's proceed. Okay, so what I'm going to do next is, let me put my x and y. So this is y and this is x. Now, what do you notice? What have I just done? This is 4 minus x squared. My x is negative. If x is negative, it's going to be looking like this. If x is negative, it's going to be looking like this. Because that means that a is less than 0. That means a is less than 0. So since a is less than 0, let me put my 2. This is 2, and this is minus 2. Okay, that's what we have. Then our vertex, x is 0, then y is 4. So look at it this way. If s is 0 and y has a number, that means this is actually y-intercept. So this is 4. That's what it is actually. If the value of x is 0 and you have a value of y, it means you have found y-intercept. Then if the value of s and y is 0 and you found x, it means you found x-intercept. So let's now plot this guy. It's going to be looking like this. That's how it's going to be looking. Let me cut out this extra. That's how it's going to be looking. Please, it's a sketch, so it's not that. I'm not even sure. I think this part from 0 to minus 2 is wider than the 0 to 2. So this is how it's going to be looking. So this is how the graph would be. That's how to sketch y equal 4 minus x squared. So right there you have it. So that's how to do that very one. The next problem, It's going to become, I think it's number 4, y equal 4 minus 4x minus s squared. So that's the next problem we're going to be having. Now, this very one cannot be solved by the mere eyes. By looking at it, it cannot be solved by that. So since this cannot be solved by it, we're going to use what we call the vertex form to plot this. Yeah, though I've not yet made a video, but I want to make a separate video on vertex form, just vertex. I'm going to make a separate video on that, well, hopefully. But very soon I'm going to make a video on that. So what I want to do here is, let me kind of rearrange this to become y equal minus s squared minus 4x plus 4. Yeah. Because the reason I'm doing this is, since I cannot easily solve this expression by factorization, I'm going to write that as a vertex. Though, like I said, this is not really that useful when it comes to Fourier. But since people watching this video might just need this for their own separate schoolwork, it's important I do it. So let us complete this square, because that's the only way to get our vertex form. Let me complete this square. So the condition is A must be unity. So which means that A is equal to 1. A must be unity, so A is equal to 1. Number 2, take the square of half the coefficient of x. Number 3, add and subtract the value of 2 above. Okay, I think I'm just going to end it. This is step 1, whatever, but I don't want to go to do that. So let us get started with this one. So they said A must be equal to 1, but A right here is minus 1. A right here is minus 1. Now, since A right here is minus 1, let me turn this around. So right now, this will become, I can factorize out this minus. I could say that this is minus bracket minus s squared over s squared, that's just minus s squared. Minus minus will give me plus, so that's 4x, and then plus 4. So this is what I have. That's what I have. Okay. So right now, the next thing I'm going to do is to say that this is y equal minus s squared plus 4x. Now, what is the half of this 4? Half of 4 is 2, right? Then take the square of it, that's 2 squared. So I'm going to add and subtract 2 squared. So I'm going to be saying plus 2 squared minus 2 squared. Take note, the reason I am plussing and minusing is because to make this expression balanced, in every equation you have to make it balanced. So if you are adding a 2 squared, you should also remove it to make it balanced. And then you're going to close this and write your plus 4, the plus 4 that has been here. Okay, now the next thing I want to do, you need to pay attention to this procedure. So this is y equal, now, please take note. When you're completing the square, it is only the plus 2 squared that is important. It is only the plus 2 squared. But take note that this minus is multiplying everything inside here. But what I need is just, hold on, let me change the bracket here. Let me change it to curly brackets. Yeah, let me change this to this. So this minus here is multiplying everything inside this bracket. Multiplying everything. But I want this 1, 2, 3. I want these 3 guys to be together. So I want these 3 to be together. So what I'm going to do is say this is minus s squared plus 4x plus 2 squared. I want them to be together. Then this minus 2 squared, this minus here will multiply this minus here to give me plus 2 squared. Because this minus was affecting every single thing inside. But right now, I want to separate them. I want this one to be separate from this. So this minus will times this, that's the minus here. And this minus will times this, and that's why we have a plus. And then put your plus 4. Beautiful. So this is y equal minus. Now, when you do this, this now becomes a perfect square. This becomes a perfect square. So this will then become s plus 2 all squared. You pick your x and you pick your 2. Since they both have squares, x plus 2 all squared. And then on this other side, this will be plus 2 squared is 4, and then plus 4. So this is y equal minus x plus 2 squared, and then this is 8. And this is your vertex form. Now, what is vertex form? Vertex form is y equal a into s minus h all squared plus k. That's vertex form. That's what it is. So with this, our vertex will then become h comma k. So if you compare it with this very one, if you compare it with this, our h here is what? Minus 2. Let me just put it at the bottom. Y equal a x minus h squared plus k. So h here has a minus, but the 2 here has a plus. So that means h has to be minus 2. So a first is minus 1, a is minus invisible 1, then h is minus 2, and then k is plus 8. K is plus 8. So right about now, this means our vertex is going to be at minus 2 comma 8. That's our vertex. Minus 2 comma 8. That's our vertex. Now, have we gotten our x-intercept? No. And that was part of the reasons we're doing this, because we need our x-intercept. We need our x-intercept. So let's come back to this part, this expression. So we know that y is equal minus x plus 2 squared plus 8. So right now, let me put 0 here. So this will be 0 equal minus s plus 2 squared plus 8. Now, can I pick this minus s plus 2 squared to this other side? Yes. When I do so, this minus will then become plus. So that's s plus 2 squared equal to 8. So this square, to remove this square, we're going to square root the other side. This s plus 2 equal to the square root of 8. But put a plus or a minus, because it's an even root. So put a plus or a minus. Now, it's actually your choice if you want to put that into your calculator. But I don't want to do that. I'm not interested in that. Though this value will give you 2.83, around that value. That's what it's going to give to you, 2.83. So we're going to say that this is x equal, if the plus 2 comes over, it becomes minus 2. So this is minus 2 plus or minus root 8. That's what we're having. This is what we're having. Okay, so what's the next thing I'll do? Now, this means that s is equal minus 2 plus root 8 or minus 2 minus root 8. That's the meaning. That's what our x is going to become. And let us now plot our graph. Okay, let us plot our graph. Now, to start with, would our graph look like this or this? Our graph will be looking like this because a is less than 0. A is what? A is minus 1. If you even look from the graph, a is minus 1. A is minus 1. So it's going to be looking like this. Now, so it's going to be looking like this. Let us put in our points. Now, minus 2 plus root 8 is going to be 0.83. So that's going to be closer to 0, but not up to 1. So I'm going to put it here, minus 2 plus root 8. Then this is minus 4.83. So that's going to be farther. So this is, let me put it here, minus 2 minus root 8. Okay. And then my vertex is minus 2 comma 8. Minus 2 comma 8. This is minus 2. Oh, sorry, that's it. Minus 2. You know that you can actually still get your vertex from this. You can actually still get a vertex. When you add this to the same method I've been using, you can still get your vertex. So this is minus 2. Remember to hit the subscribe button. Comment. If you're loving this video, please comment. So that's minus 2. Then 8 is going to be at the top because y is 8. So let me put 8 here. Okay. So now let me plot my graph. It's not going to look that fine. Let me see, but I hope it looks fine. Okay, so this is 8. And yeah, that's how it's I'm sorry, it's not looking beautiful, but this is how it's supposed to look. This is how it's supposed to look. So this is what we have. This is how it's supposed to be drawn. Remember to download Desmos. It's going to help you draw some graph. Yeah, that's Desmos. Very fine handwriting. So let us proceed to cubic. Did I really write that? Okay, I'm going to just solve a few questions on cubic, just a few. Let's start with that's a lot actually. Y equal as cubed plus bs squared plus cx plus d. But first of all, the graph will be looking in two ways. Let me put this first one. Let me put the second one. Okay. Okay. So it's either this or this. This is y, this is x. This is y, this is x. So the graph will look like one of these two. It's either starting from here all the way to this point. So this very one you see here is y equal to s cubed. Then this very one you see here is y equal minus s cubed. So these two that I've just stated, they're very, very important. The same way you know if your graph is going to be like u, okay, like an n or like a u when it comes to quadratic. That's how you should know how it's going to be looking like. It's very, very important. So let me just do one on this, please. Just one. Okay. So let the first one be s y equal s cubed plus plus 7s squared plus 10x. Okay, I think I should let me just do that one. Yeah, I don't really want to stress myself that much. So let me do that one. So y equal s cubed plus 7s squared plus 10x. So the first thing I want to get is my x-intercept. So that one is easy. If this is s cubed, it's going to be starting from here. It's going to be starting from here. So that's what we have. So this is s cubed. So I'm going to say s cubed plus 7s squared plus 10s is equal to 0. Now, if you notice here, s is common, right? So this is s bracket. Let's factorize x out. S cubed divided by s is s squared plus 7s squared divided by x is 7x. And then plus 10x divided by x is 10 equal to 0. So we've been able to factorize. And if you notice, you can also still factorize this one, right? Because what can you times to give it 10? Add it to get 7. The numbers are 5 and 2. 5 times 2 is 10. 5 plus 2 is 7. So that's it. So this will be x bracket s plus 5 bracket s plus 2 equal to 0. Remember I said something. I said I'm not actually teaching how to solve quadratics. I believe you can solve quadratics. That's why I factorize very fast. Please pardon me if that's too fast. So this is what we have. Now, if every single thing here is equal to 0, it means any of them could have been 0. So this means that s is equal to 0, or s plus 5 is equal to 0, or s plus 2 is equal to 0. So this is s equal to 0, or if plus 5 comes to it becomes minus 5, or if plus 2 comes to it becomes what? Minus 2. Now, ideally, it is also important that you know the vertexes, because we're going to be having 2 points here. But in this case, I'm not really going to take it into cognizance, and that's not nice. That's not nice, but just a sketch. I'm not going to take it into cognizance in this case. Oh, okay, let me just do it at the top. Let me do it there. Because I'm going to show you why I said we're supposed to find it. But I'm going to be making separate videos. I have lots of videos to make. So right now, this is 0. That's 0. This is y. This is x. Then I have minus 5. It's going to be at the extreme end. I have minus 2 and then 0. Okay, so right now, my graph will be passing through all these points. Now, because it's an S cube, it must start from this part, this quadrant. I'm going to be having something like this. Oh, that's weird. Okay. Ah, God. Okay, so that's how it's going to be looking. Yeah. Was that fine? That's how it's going to be looking, just like that. That's how it's going to be looking. Yup. Yeah, yeah. Aha. Okay. So that's just that. So that's all I would just want to do. I don't want to do more than that. So this is just what it's going to be. So let's go to trigonometric. Let's go to trigonometric. For this one, we have sine and cos. That's the only two I'll be treating. So we'll have sine and cos. Now we know they're periodic with 2 pi. Yeah, we know that it's a periodic function, so it always repeats with 2 pi. So let me start with sine x. So I kind of have something like this. Ooh, yeah, something like this. Let me put 2 pi here. I would have said 360, but let me just put 2 pi there. Now, the first thing you want to notice about this kind of graphs, trigonometric graphs, is there's always something called an amplitude, which is the maximum displacement. So there's something called an amplitude. So the amplitude is the highest point we can get. In this case, amplitudes are always the coefficients. So right now there's an invisible one here. That means there must be, the height is 1. So it's 1 to minus 1. That's it, 1 to minus 1. So that's the maximum point. Now to draw this, you're just going to be having something like this. That's just what you have. So the maximum, it's not kind of fine, but the maximum is going to be a +1, and the minimum is this. So this is what you have, 0 to 2 pi. So that's actually very, very simple. Look at the second one, 2 sine x. Now how would 2 sine x be? It's still going to be similar to this. It's still going to be similar to that. That's 2 pi. It's still going to be similar to that. But, now please take on this minus pi, actually. No, that's just going to be pi. So, this very one here, this thing you see here, this very one that you see here, is going to become 2 is the highest point. 2 is going to be there. So, this is going to be 2. It's going to be minus 2. They're going to have something like this. That's just what it's going to be. You see that, right? So this is how 2 sine x would be. So it's 2, when it comes to sine x, you're always starting from 0. You're always starting from 0 for sine x. So let's go to the next one. So what if we have number 3? What if we have sine 2x? Now take note, whenever I have a multiple with the x, that tells me how many cycles occur within a single period. I know that the period is 2 pi. So if I have 2x, it means I'm going to be having 2 cycles. In this case, I have just 1 cycle. Because this part, if you should move this to cover this part, you see that it's like 1 cycle. So this is the half part, this is the half part, half and half. They kind of, if this is being rotated, if you shift it to match up with this very part. So, but in this case, this is now 2x. This is now 2x. So you're going to be having 2 cycles from 0 to 2, but instead of it containing just 1 cycle, it's going to be having 2 cycles. So let's see what it's going to be. This is 2 pi. This is pi. This is +1 because the amplitude is 1, and this is -1. So let's see. I'm going to be having something like this. That's not fine. Sorry. That's not looking fine. Hold on. Let me see. It's not looking fine. Let me just clean this other part. Okay. But please, I hope you get the picture. Yeah, I kind of do hope you get the picture, because this is how it's going to be. So yeah, that is how you're going to have it. just like that. So right now we have 2 cycles before you get to that period. These 2 parts will become 1. These 2 parts will become 1. So that's just how to draw that. So when it comes to sine x and the rest, it's actually very simple. So let's talk about cosine. Let's talk about cosine. Number 4. Take note, you might need to put the negative part. If you needed, let me say, the one to minus pi, for example. Now let me use this one since there's more space here. If you needed the one that extends to minus pi, that means you're going to be having something like this. Something like this. So if they say from minus pi to pi, this is going to be looking just this part. So something like this. So it all depends, please. Now for cosine of x, for cos x. Okay, so for cosine, plus 1, because the amplitude is 1, minus 1, this is 0. Okay, so the maximum of this will be plus 1. And another cos 0 is 1, so it's going to be starting like this. So right now, let me put this like this. Oh God. Should I say, the size of each of them is not matching up to what I want, but it's still doing what I kind of need. So this will become my pi over 2. This will become my pi. Yeah. That's what my pi would look like. And this will become my 3 pi over 2. And this one will be my 2 pi. Yup. Yeah, it's looking, that's how it's going to be. Looking like that. Yup. It's looking like that. So that's how it's going to be. This is how it's going to be. Now, if you need it to be at, what's it called? If you need it to be at the minus pi part of this, it means you're going to be having something like this. No, just like that. That's how it's going to be. Okay. So I've been able to show you cosine of x. So that's how it is. Now, if it is 2x, you know what to do. If it is 2x, it means instead of you having just 1 here, we're going to be having 2, like double of it, multiples of it. So I don't want to dwell on that. Let's go to piecewise, and that is why you are here. This is what you are here for. Piecewise. That is what you've been waiting for ever since. So let us finally do it. A piecewise function is a function that has different rules for the range of x or values of x. So also, a piecewise function do not overlap. Here's what I'm trying to say. If you have f of x equal to, let's say, 3, 0 less than s less than 4, then 5, 4 less than s less than 6, something like this. Take note that you cannot be having equal to on both sides. In real sense, please. I know that when it comes to Fourier, I don't know, some expressions are being written weirdly. But two values cannot be overlapping. So you cannot be having s equal to 4 here, and this is also equal to 4 again. So you can't be having that. So, but let's just leave that part. Let's start what we are here for. Remember, this is why you are here. This is what you've been waiting for. So let's start with the first one. The first one, and let me just call it A. So A says f of x is equal 4, 0. 0 is less than s less than 5, and 5 is less than s less than 8. So let's plot this one. So first of all, we know that it's going to be starting from 0 down to 8, so we only need positive parts of x. So this is x. Let me put my 0 here, that's 0. Let me put 5, so this is 5. Then let me put 8, so this is 8. So the first thing I'm going to do is, this is f of x, or which you call y. So it is equal to 4. So let me put 4 here. It's equal to 4 all the way from 0 to 5. So when it was 0 to 5, the value remained the same all the way from 0 to 5. It was the same. Then you bring it down. 0 to 4 was the same. Take note that this vertical line does not matter. So it was the same. Then it was 0 from 5 to 8. So all you have to do is to kind of tick in this part because this is 0 line. This is the 0 line. And that's just it. You've been able to graph that function. That's just what you have to do. You've been able to graph it. This is not looking fine. You've been able to graph the function. That's just it. So this is the answer to that very first question. Let's move on to the next one. There's no time. The next one is where problem starts coming in. B. F of x equal pi plus x from minus pi to x to 0 and pi minus x from 0 to x to pi. Okay, so let us plot this very one. Now remember that I said for me to have linear, when a line is linear, this is just x. For me to have linear graphs, I deal with the intercept. So the first one is pi plus x. So if I have f of x, which is y, so if y is equal pi plus x, what will be my x-intercept? Or you can see, this is 0 to minus pi, right? This is 0 to minus pi. So I can first of all say, okay, what is my y-intercept? When I put x as 0, y-intercept will be what? Pi. Y-intercept is pi. So y is equal to pi. Y is equal to pi. That's it, right? Good. So if y is equal to pi, when x is 0, let me say this again so you understand clearly. If you notice our interval here, this is s0. So when s is 0, if we should put 0 here, pi plus 0 is still pi. So y is equal to pi. That's why I said y is equal to pi when s is 0. Then the next value of s was minus pi. So if we should put minus pi here, so s is equal to minus pi. If we should put minus pi here, pi minus pi, because s is now minus pi, pi minus pi is what? 0. So y is equal to 0. You see that, right? So you've been able to get that guy. Let me draw this so we kind of spot what's going on. So this is minus pi, this is my 0, and this is my pi. Okay, and this is my f of x, or you could just say that's y. So right now, the first thing we have is the pi plus x. Now when s was 0, y was pi. So when s was 0, y was pi. So let me put my pi here. So let it be this point. So when s was 0, y was pi. Then when s was minus pi, this is minus pi. When x, this is my x-axis, when s was minus pi, y was 0. So it's going to be here. Take note that these two things are like intercepts. When x is 0, you have found the y-intercept. When y is 0, you have found the x-intercept. So that was what we did here. So right now, I can then connect this with a straight line. That's not looking fine, but yeah, you kind of get the picture. That's what I have. Now the next part is y equal to pi minus x. If you notice, the 0 part is still the same. So when s is 0, the value will still be the same because that's what we have. So let us put 0 here. So this is 0. Pi minus 0 is still 0. So y is equal to pi when s equal to 0. I don't want to be writing that. It's going to make the video longer. So s is 0. Pi minus 0 is pi. So y equal to pi. That's the first part. And this is pi, right? Good. If this is pi, when you put pi here, what will y become? Pi minus pi is 0. So y is equal to 0 when s is equal to pi. So again, this part has been plotted already. So y is equal to pi when s is 0. So s is 0, y is pi. That has been plotted already. Then the next one, s is pi. So this is pi. And then y is 0. So this part too. And that's just it. You've been able to plot that graph. So that's how to plot that one. That's actually very easy for you to plot. C, the next one. The next one. So we have f of x equal, that's a lot, x over 2 at 0 less than x less than pi, and pi minus x over 2 at pi less than x less than 2 pi. Okay, so let's do this. This one is still easy to plot. It's still easy to plot. So the first thing is f of x is s over 2. So f of x is x over 2. So the first thing is when s is 0, because we have x at 0. So when s is 0, when s equals to 0, what will y become? This is s, right? And s is now 0. So this is 0 over 2, which is just going to be 0. So we have 0 at 0. So we have 0 at 0. Okay, so let's proceed. The next one, when s is pi, when s is pi, when s equal to pi, y will become, if you should put pi here, this will become pi over 2. So y is pi over 2. Okay, let me plot my graph somewhere here. So this is x, then this is y. Okay, so look at this. We're just having x over 2, right? So put 0 here. 0 over 2 is still 0, so y is 0. We're having pi, s is equal to pi. So put your pi here. This will be pi over 2, so which is what we have here. Okay, so let's plot this guy. So we have, this is from 0 to 2 pi. Oh, so we have only the positive parts. Let me adjust my y line. Let me adjust my y line. This is y, this is 0. Okay, so let me put pi here, and let me put 2 pi here. Okay. So let me put this guy here to be pi over 2. Let me put my pi over 2 to be, because we have y equal to pi over 2. So the first things first. When x is 0, y is 0. What does this tell you? This is the origin. When s is 0, y is 0, that's the origin, because this is 0, 0. So this is the origin. So there's a point right here. Then when x is pi, when s is pi, y is pi over 2. So when you sketch this, and so this will be here. That's where that point would be. So right now you can then connect this together. And that's what we've just done. We've connected that together. Okay, let's go to the next one. So when f of x is pi minus x over 2. So the first value we had was x at pi. So when s equal to pi, when s is equal to pi, this means my y will become, now take a look at this. I think I'm going to write this one because this is a lot. So we have pi minus x over 2, which is now pi over 2. So what is pi minus pi over 2? Pi minus pi over 2 is pi over 2. Let me put over 1 here. So the LCM of this is 2. 2 divided by 1 is 2. 2 times pi is 2 pi. Minus 2 divided by 2 is 1. 1 times pi is pi. So 2 pi minus pi, that's pi over 2. So that's what we have. So when s is equal to pi, y is equal to pi over 2. Okay, so that's what we have. Now the next one is 2 pi. So next, when s is equal to 2 pi, what would our y become? So we know that y is pi minus s over 2, right? So this is pi minus x is now 2 pi. So this is 2 pi over 2. So 2 we cancel 2. So we have pi minus pi remaining, which is what? 0. So when s is equal to 2 pi, our y is equal to 0. So sometimes I always say that sketching these graphs are always the easiest. Piecewise, they're always the easiest. So when let's do this guy. When s is pi, y is pi over 2, which is the same thing here. When s is pi, y is pi over 2. So it's the same thing. We've plotted it before. So right now, next one is when s is 2 pi, y is 0. So it's just going to be here. This is like saying our x-intercept, because y is 0, s is 2 pi. So our intercept will be at 2 pi. So you connect these two together. And that's it. You've sketched that function. So these are looking like our top hat function. But let's continue. So this is what we have for the 2. D. the d part of this. Okay, so f of x is equal, this is looking like a lot, but let's continue. 3x over 4 from 0 less than s less than 4, and 7 minus x, 4 less than s less than 10, and minus 3, 10 less than s less than 13. Okay, so this is what we have. Okay, that's still not hard. That's still not hard. Okay, so let's get started, please. Let's get started, please. It's actually very easy. So the first one is 3x over 4. So let's start with when s is 0. So when s equal to 0, we know that y is 3s over 4. So if you should put s as 0 here, 3 times 0 is 0. 0 over 4 is still 0. So this will be 0. So you have s at 0, y at 0. So the next one is when s is 4. When s is 4. So when s equal to 4. We know that y is 3x all over 4. So if s is 4, this is 4, right? So 4 we cancel at 4. 4 we cancel at 4, meaning you have just 3 remaining. Easy. That's easy. That's easy. Let me clean this part. Okay, so yup. Nah. Okay, so this is 0, 0. So this is f of x. Yep. Okay. So from 0, the equation is from 0 to 13. So we have 0 down to 13. And from that 0 down to 13, we have 0 to 4. So this is 0 down to 4. And then 4 down to 10. And then 10 to 13. So right now we have the first one. The first one that we have was 0 and 0. So that's the origin. This is the origin. Then when s was 4, y was 3. When s was 4, y was 3. So this is 3 here. So when you trace this guy and this point, so it's going to be here. Yeah. So this is what we have. So I have this guy like this. Okay, so that's for the first one. That's for the first part. Now the next one is 7 minus x. Sorry that I'm going to... So 7 minus x. So for 7 minus x, I'll say when s equal to 4, when s is equal to 4, we know that our y is 7 minus x. So if s is 4, what is 7 minus 4? 7 minus 4 is 3. So we've been able to get that point. The next one is when s is 10, y will become 7 minus 10 because it's 7 minus x, right? So 7 minus 10 will give us minus 3. So let's come back to our graph. So when s is 4, y was 3, we've been able to plot that. When s is 4, y was 3. Good. Next, when s is 10, so there's a point here, please. There's a point here. So when s is 10, y was minus 3. Minus 3. So let me put my minus 3 here. So if you kind of use a ruler, they're going to be intersecting here. So we're going to connect these two together. Yeah, because these are the two. This very one here is the 4 and 3. Then this very one here is the 10 and minus 3. So you've been able to connect them together. Next is minus 3. Next is when is what? When is minus 3. So minus 3 is just a horizontal line. This is your minus 3 here. So minus 3 is just a horizontal line. Just this horizontal line. And it's going to be ending at what? 13. It's going to be ending at 13. So that's just it. And that's it. You've been able to plot or sketch that guy. So this is just it. Sometimes, please take note that this line might not be, this vertical line is not that important. So it might not actually be drawn. Because in real sense, this is just what your graph should be. That's just what your graph should be, ideally. That's what your graph should be. Though it should be open here. I didn't really specify about the opening and the closing of points. You know, we're doing Fourier. But ideally, this point is supposed to be open because this is less than 13. If it was closed, I'm going to close it here. But since it was not, I'm just going to leave it like that. In this case, we don't want to pay attention to this. But in real sense, if you're plotting that guy, you should actually put that. Let's go to the next one, please. There's no time. Let's go to the next one. So for the next one, that's E. So for E, we have f of x at 7 minus 3x over pi. So this one is minus pi less than x less than pi. Okay. This is actually very easy. It's very, very, very easy. So for the first one, since every single thing here is just a straight, it's like a straight path. It's a straight path all the way from minus pi to pi. Let's put in minus pi first. So when s is minus pi, when s is minus pi, y will become, you can do this by looking at it, but let me just put it in. So this is 7 minus 3 into minus pi over pi. So when pi should cancel out pi, minus 3 times minus will give me plus, right? So 7 plus 3 is 10. So I have that one. Look at it this way. If pi should cancel out pi, you have a 1 here. Minus 3 times minus 1, that's plus 3. So 7 plus 3 is 10. So the next one is when x is pi. That will become 7 minus 3 pi all over pi. So this will cancel out this. So 7 minus 3, that's 4. So now let's plot this. Let's plot this. Remember to hit the subscribe button and like this very video. Okay. So I'm going to be drawing my graph. And it's from minus pi to pi. And the y line is going to be at s equal to 0. So this is 0, 0. This is my y or my f of x line. So when s is pi, when x is pi, we have y at 10. Okay, so let me put my 10 here. That's a lot. Yeah, let me put my 10 here. So when x is at minus pi, we have it at 10. So the intersect, these two guys together, when you trace this point to this point, it's going to be somewhere here. Then when s is pi, y is just 4. Let me say my 4 is somewhere here. Let me say my 4 is somewhere there. So together, it's going to be here. So I'm then going to connect a line to these two. And that's just it. Yeah, that's just what it's going to be. So that's for that very one. That's for that very one. Let's move on to the next one. So f. So for f of x is x at 0 less than x less than pi over 2. And then we have pi minus x at pi over 2 less than x less than pi. Yep, my main aim is to just sketch this. So first of all, this one is actually easy. You know how x looks like because we've done it before. We've done something like that. So right now, the first one is when s is this very 0 you see here. When s is 0, what will y become? We know that y is equal to x, so y will still be 0. Because this f of s equal to s means whatever you give to it is what it's going to give to you. So the input is equal to output. Because the input is directly equal to the output. So f of s, or you could say y is equal to x means whatever s is what y would be. So the next one, when s is equal pi over 2, this also means that y would also be pi over 2. So no stress. So that's what we have. That's what we have. Okay. The next one, for the second one, when x is equal pi over 2, because that's the first value here for the second one, when s is pi over 2, we have our y equal to pi minus x. But our s is now pi over 2. So this is pi minus pi over 2. Now, we've done this earlier on. I think that was question C. So pi minus pi over 2 will give us pi over 2 again. So this is what we have. Then the next and the last one is when x was just pi. When s was just pi, our y was pi minus x. So this will become pi minus pi. So that's 0. So that means the point we have is s equal to pi. We have the point s equal to pi, y equal to 0. While here we have s equal pi over 2, y equal pi over 2. So let's sketch our graph. So this is y, this is 0. This right here is, we have all the way from 0 to pi. Then in between, we're going to have pi over 2. Okay, so right now, we're going to say that we have 0 and 0, that's the origin. So the origin is involved. Then we have pi over 2 to pi over 2. So y at pi over 2, let me put pi over 2 here. So when s is pi over 2, y is pi over 2, so together, they'll kind of meet at a point like this. Okay, then the next one, I'm going to connect this with a line first. So the next one says s is pi over 2, y is pi over 2, which is the same as this. So we've plotted this already. So the next one, when s is pi, y is 0. So when s is pi, y is 0, so which is this point here. Remember I said, if one part is 0, it means you have found the intersect of the other. So y is equal to 0, meaning we are finding the x-intercept. So x-intercept. So that's going to be there. So connect it like this, and that's what you have. So that's how to plot that very one. That's how to sketch that very one. Okay, the next one is g. So for g, f of t is equal minus 1 from minus 1 less than t less than 0 and 2t from 0 less than t less than 1. Okay. Now, sketching minus 1, that's not a problem. It's just a horizontal line. So let's leave that. Let's go to our 2t. 2t is still very easy, actually. So let's go to 2t, please. So f of t is equal to 2t. Now, when t is 0, I know how this line is going to, this line is going to look like this one. It's going to look like this one, but it's going to move. Yeah, it's going to look like this one. It's going to move either like this or like this. So when t is 0, when t is equal to 0, y is going to become 0 because this is 2t, right? So it says that whatever t is, you're going to double it to get your y, to get your f of t. You're going to double it. So if you double 0, it's still 0. Then when t is equal to 1, y will become 2 because if you double 1, you're going to get 2 because the function is just 2t. 2t means twice. That's going to become what you have. I can even plot this thing here. Yeah, I can even plot it here. So this is our t, and this is our f of t. So to start with, we have minus 1. So let me put minus 1 right here. Then my t value is from minus 1 to 1. So this is minus 1, this is 0, and this is 1. At the first point, they said from minus 1 to 0, we're having minus 1. So from minus 1 all the way to 0, the value was minus 1. So you have something like this here. Just that. So that's just a horizontal line. Now, if you wish, you can connect this together. If you wish. So that's what it's going to become. Then next, from 0 to 1, that's this point, we notice that the origin was included, 0, 0, so the origin was included. And then when t was 1, y was 2. So let me put 2 here. It's going to be like this. Okay. So that's just what it's going to be. And then, yeah, that's not looking straight. Oh no, this is even bent. Sorry for that. Okay, that's what we have. That's what we have. Okay, so that's for that. So let's go to the next one, GH. So for H, f of x is equal x plus pi over 2 from minus pi to x to 0 and x minus pi over 2 from 0 less than x less than pi. You know, sometimes when you see functions, you know that these functions are actually similar. Yeah. So functions are looking like repetition of what we've done before. But anyway, let's see how fast we can just do everything so we wrap up this episode. So for this one, I'm going to do much more fast. In a way, much more fast. So let's see. So for this one, we have this. So let's start with the first one, x plus pi over 2. So when s is minus pi, when s is equal to minus pi, hold on, let me see if a new marker would help. Let me see. So when x is minus pi, that means f of x, which is our y, would then become, if we should put minus pi here, s is minus pi, right? So minus pi plus pi is 0, and 0 over 2 is just 0. Let me say that again. The function is s plus pi, right? And we now have that s is now minus pi. So if you put s as minus pi here, minus pi plus pi is 0, and 0 over 2 is just 0. So that's the first point. Then the next point here is 0, right? So when s is equal to 0, which means we're going to be having 0 plus pi. 0 plus pi is pi, so that's pi over 2. So f of s is equal to pi over 2. So keep this, that's our first point. The next one, when x is 0, because for this second one we have x at 0. So when s is equal to 0, what's going on? Okay, let's see. So when s is 0, if you should put 0 here, 0 minus pi is minus pi. So this is minus pi over 2. So we have f of x equal to minus pi over 2. Okay, then when s is pi, when s equal to pi, f of s will then become, we should put pi here, pi minus pi is 0. So 0 over 2 is 0. So, like I said, this is actually very simple. So let's plot our graph. So it's from minus pi to pi. So minus pi down to pi. Then 0 is at the middle. Okay, then this is f of x. So the first one says when it's at minus pi, f of s is 0. So this is just this part. Because for you to say f of s is 0, remember that f of s is y, so do not be confused. So f of s is 0. So that means we have this 0 guy here. And this is x at minus pi. So the point is going to be here. X-intercept. Then when s is 0, y was pi over 2. So this is pi over 2. This point here. So these two will be joined together. Yeah, that two will be joined together. Then the next one is when s is 0, f of s was minus pi over 2. Now this is 0, right? They said y is minus pi over 2. So let me put my minus pi over 2 here. So that means this is an intercept. Because now s is 0. If s is 0, it means you are finding the y-intercept. Remember I said that when we started this video. When s is 0, it means you're talking about the y-intercept. So that's what we have. Okay, then when s is pi, f of s is 0. So you have it right here. So yep, this is what it is. So that's your graph. So this is what the graph is going to be for that function. That was easy. So that's it. The next one, that's h, this is I. This is I. Yeah. So this one says that f of x is equal 1 minus x at I think I want to change this. Oh yeah, I don't want to look like, hold on. Mm, uh, hmm. Okay, let's just see. Minus pi less than t less than, okay, no, this is x. Then 1 plus x at 0 less than x less than pi. There's a particular function that I'm looking for, and I have still not seen it. But anyway, let's hope for the best. There's something I wish to explain here. Let's see as we go, as we proceed. As we proceed, let's see. Okay, so to start with, when s is minus pi, this is weird. So when x equal to minus pi, y will become, we know that this is 1 minus x, right? So that is 1 minus, x is now minus pi. So this means we'll have y equal to 1 plus pi. That's weird. But let's proceed. So y is equal to 1 plus pi. Then next, when s is 0, y is just going to be 1. Because when you see 1 minus 0, that's just 1. So I'm going to keep that point. I'm going to keep that point. I'm going to keep that point. Okay, then the next one is when x is, because I'm doing this next one now, doing the next one. So when s is 0, again, when you say 1 plus 0, that's still 1. So y is equal to 1. Okay, and then when s is equal to pi, when s is equal to this very pi, because I'm dealing with this second one. When s is equal to pi, I have y equal to 1 plus pi. Okay, now 1 plus pi is about 4 point something. So let's plot this guy. Let's plot it. Okay, so it's from minus pi to pi. There's a 0 here. So let's see what this will be. This is somehow. Okay, so when s is minus pi, this is minus pi, we have y at 1 plus pi. Okay, let me put 1 here. Let me put 1 here. And let me put 1 plus pi above it. Because 1 plus pi is bigger. It's bigger than 1. So when s is minus pi, y is 1 plus pi. So this is minus pi, and this is 1 plus pi. So it's going to be somewhere here. Yeah, it's going to be somewhere here. Okay. So when you take this point here and this point, it's going to be somewhere there. Then when s is 0, y is 1 plus pi. So this is 0, and this is 1 plus pi. So that's just this point here. When x is 0, y is 1. So this is telling us that, oh, our y-intercept is at 1. Our y-intercept is at 1 because s is 0. So y is 1. So you're only going to the point where y equal to 1, and that's where you're going to be dotting. So these two will be connected together. Yep. Will be connected together. So that's what you have. Then the next one is when s is pi, because this point 0 and 1 is still the same with this. So I'm leaving it. I'm going to this very one. When s is pi, y is 1 plus pi. So this is pi. I think it's too far safe. The same 1 plus pi. So it's going to be somewhere here. And it will be joined together with this. Yes. And this is what you have. That's how the function will look like. Yup. It's fine, isn't it? That's how the function would be. So this is what you have. Let me give you some time to look at it and see if you understand it. Remember to hit the subscribe button, like this video, and share it across to your classmates. Let us proceed. Let's proceed. Okay, this is beautiful. It is. So J says we have f of x equal 2 sine x from 0 less than x less than pi, and then 0 at pi less than x less than 2 pi. Okay, let's get started. So first of all, when x, the first thing you need to know is this is like a curve. It's curved. It's not going to be straight, so be very careful. It's not going to be straight. So when x is equal to 0, I still want to do the same principle here so you understand. Y would then become, we have 2 sine x, right? So this will be 2 sine 0. And sine 0 is 0. So when you times that by 2, that's still 0. The next one, when s is pi, when x is pi, y will then become 2 sine pi. 2 sine pi. And we know that pi is equal to what? 180. Pi is equal to what? 180. Are you sure this one will do this thing very well? This is also, pi is 180, so sine pi is 0. Times 2, that's still 0. Okay. Okay. This one is not difficult to draw. But from this point, I want to do something. Let me draw this. Let's see. So this is 0, this is pi, and this is 2 pi. And then this is x, and this is f of x. Okay, so when s is 0, y was 0. So that is this point we see here. Good. Then when x is pi, y was 0. So which is this point here too. When s is pi, y was still 0. Okay. Now, you know that this is supposed to be like a curve, right? It's supposed to be a curve. So now take note. Take note. How do we then plot this? Remember that I said when you're plotting sine, that the number in front tells us how high the height of the diagram. So the height here is going to be 2. And since we're dealing with the positive part, since we're dealing with this part, this very part here, we're going to say that there's going to be a 2 here. There's going to be a 2 at this very point. Because 2 is going to be the maximum. It's going to be the highest height of this very function. It's going to be the highest height of this very function. Okay, so what I'm going to be having is going to be something like this. Let me see. I've told you the importance of these 2. Giving you the importance of that guy. Then, okay, so it's going to look like this. Yeah. That's how it's going to be. It's going to be like that. Where this maximum height is pi over 2. Where this maximum height is at the middle, pi over 2. That's how it's going to be. That is how it is going to be. Sometimes I kind of try to remember what I've done before to see if I did the right. Yeah, I think I did the right thing. Okay, so please, if you notice any mistake, please let me know. So this is what we have, because I can make a mistake. But let's see. I think every single thing is all right. Okay, then when it's at 0, this is just going to be a straight line or a line that collapses at this very point. And that's just it. That's just how to draw that graph. That's just it. Yeah. Okay, the next one is k. So for k, we have f of x equal to 0 from 0 less than s less than pi over 2. And then it is cos x at pi over 2 less than s less than pi. Okay, now for this one, let's deal with our cosine. So when x is equal to pi over 2, what is the cosine of pi over 2? Cos pi over 2 is equal to 0. Cos 90, you check this in your calculator. Cos 90 is 0. Cos pi is 180. 180 over 2 is 90. Cos 90 is 0. So the next one, when s is pi, because we're only dealing with this one. When s is pi, y will become cos pi, which is equal to -1. Okay, so let's plot this. Let's plot this. So we have from 0, and then we'll have pi over 2, and then we have pi, and this is x, this is f of x. Okay, so from 0 to pi over 2 was a flat line at 0. There was a flat line here. Then, when we got to pi over 2 to pi, now we then take note of this. So the only point we have was pi over 2, so 0. When s is pi over 2, y is 0. So come here, this is s at pi over 2. So that means this point is inclusive. Then the next one is when s is pi, y is -1. So this is x, and this is, let me put -1 here. So that's this guy here. Take note, don't connect them by a straight line because cosine is not linear. Cosine is not linear. Now, this very graph you see here is also like a parabola. It's also like a parabola. So what we're going to have is, how do we then connect this to this? Because you need to be correct when you are doing this. So let me kind of draw this guy. Let me draw separate cosine. Let me just draw separate cosine from -pi to pi, because that's 2 pi. It's going to be looking like this. This is 0. Yeah. So you see how it's looking? That's how it's going to be looking. Yeah, that's how it's looking. So it's looking like this. Okay, so this guy you see here was just supposed to be something like, this is your pi over 2. So it's going to be like a curve, something like, I hope I did very well. Nah, that's not fine. Let me do something. Okay, so I'll put my pi here. I think this one is my pi. Okay. Okay. I think, yeah, but this is not inclusive. Okay. Yeah, it's not looking fine in my eye, so that one is better. That one is better. That one is better. Okay, so let me proceed. Let me wipe this part. Okay, so we have f of x equal to t plus pi, t minus pi, minus pi less than x less than 0, and 0 less than x less than pi. Okay, now do you know what? I want to leave this one for you. I want to leave this one for you to do. Try this out yourself. You can let me know the answer when you send me an email. So you can send me an email. I'll then check what the answer would be. So I think I'll leave that one for you because it's looking similar, like it's looking like H. Yeah, it's looking like H. It's supposed to. So follow what I did in H to do this one. It's similar to it. So let's not make this long. So it's kind of looking like this. Yeah, it's kind of looking like this. So it's looking like H. So I've even drawn it, so you can just do that one yourself. So that's L, then M. F of t is 1 minus t squared from -1 less than t less than 1. This is actually the easiest to draw. Do you know why it's the easiest? If you should solve this quadratic, your answer is -1 or 1. If you solve this quadratic, that's your answer. So let me show you how. This is 1 minus t squared. So this is y equal to 1 minus t squared. So this will then become 0 equal 1 minus t squared. Take the t squared to this side. So this is t squared equal 1. T is the square root of 1 with a plus or a minus. So t is plus 1 or minus 1. So that's why I said that's the answer. So this is actually very easy for us to draw. I'm going to have something like this. So this is minus 1, this is 1, this is 0, this is t, and this is f of t. Now take note, this is where it becomes much more critical. Will this graph look like U or, sorry, why do I like calling it on U? Will this look like an N or a U? Would it be open upwards or open downwards? Now, since this is a negative t squared, since this is minus t squared, it's minus t squared, it means that it's going to look like this one. This is going to be, because this is when a is less than 0, while this is when a is greater than 0. It's going to look like this. So your graph is actually like this. Yeah, that's really like that. Now, if you're bothered about the vertex would be at 0. Why would it be at 0? If we should add these two together, minus 1 plus 1 over 2. So this would be, hold on, did I say 0? Hold on. Minus 1. Our solution is this. So this is 0. No. Our vertex would be at x at 0, or should I say t at 0, then 1. So it's going to be at, yeah, it's correct, it's 1. So t is 1, this is 0, so that's how it's going to be. So it's going to be at this point. So yeah, I was correct. Okay. The next one is n. The next one is question n. Don't worry, we're almost done with this. Almost done with this. Almost done. So let's see, this is n. So for n, we have f of x equal x bracket pi minus x. And this is from 0 less than x less than pi. So that's actually an easy one to draw. It is actually an easy one to draw. It is an easy one to draw. Okay. Now, let me put, because the thing is, you just have to know what you should do at some point. So I feel like what I want to do is to put in my 0 and put in my pi. Or better still, I could say that, this is normally y. So this is 0 equal to x into pi minus x. So any of them could have been 0. So this s is equal to 0, or pi minus x is equal to 0. Don't know why. Okay. Yep, that's looking better. So this is s equal to 0, or this here actually means that pi is equal to x. If we should take the minus s to the side, pi is equal to s, or you could say s equal to what? Pi. So it means that your x-intercept would be at s equal to 0 and s equal to pi. Yep. So this is what it's going to be. Then what do you think would be your vertex here? Your vertex will become xv. The x value for the vertex will be 0 plus pi over 2. So this will then become pi over 2. So that's the x value for the vertex. Then the y value for the vertex is, take this pi over 2, put it back into this expression. Put it back into that expression. So that will be pi over 2 brackets pi minus pi over 2. Because anywhere you see s, you're going to put pi over 2. So this is x, pi over 2, pi minus this is s again, pi over 2. This is pi over 2. Pi minus pi over 2 is pi over 2. We've done this before. So this will just become pi squared over 4. Okay, so let's then plot it. Okay, I have just from 0 to pi. So this is 0, and this is to pi, and this is x, and this is f of x. Okay. Okay, let me put my pi over 2 here. Yep. So I know that upon expansion, if I should expand this, I'm going to be having pi x minus s squared. So my parabola will still look like this because the s squared is negative, so it's still going to look like this. Then, so it's from 0 to pi, so it's going to be like a dome. It's going to be like a dome. So that's it. Then this point here, which is the maximum, the value of y here is pi squared all over 4. So yeah, that's it. Oh no, that's too high. So that's how to plot that very one. That's how to plot it. And the last question for the day. 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 Let me see. Okay. I think I might, should I add? I think I might add one more though. But let's proceed. So this is O, because there's a question I just remembered. F of x is equal s squared over 4, 0 to x to 4, then we have 4 from 4 to x to 6, then we have 0 from 6 to x to 8. Okay, now here's one thing I want to say about our parabola s squared. So s squared, if you divide it by something, you are making it wide. Let me explain. If normally this is our s squared, and you divide it by something, you're going to make the s squared open up more. But this is when you divide by something. But if you should times s squared by something, you're going to make it much more tinier. So right now, your division by 4 is going to make this thing much more wider. But let's proceed. What I've just said might not be useful to plotting this, but the knowledge is very important. But you can still do this, you can still solve this without stressing yourself. So now we know that if s is 0, please take note, if s is 0, when s is 0, y would also be 0 because 0 squared is 0. So 0 over 4 is 0. Then when s is 4, 4 squared, y would then become 4 squared all over 4. So which is 4, right? Because 4 squared is 16. 16 over 4 is 4. So that's what we have. So that one is much more easy. But please take note, because s is equal to y here, s also equal to, does not mean that it's a linear expression. It is quadratic. So it's going to be a parabola. So let me do this. Then, yeah, s is just 0, 0. If you solve this expression, s is at 0. So what I'm going to be having is going to look like this. Yeah, so we have from 0 down to 8, and then from 0 to 8, we have 0 to 4, and then 4 to 6, and then 6 to 8. So now let's get started. Let us get started. So this is y equal to 4. So let me put my 4 here. Now I have this and I have this. If you look at this graph, s squared is normally like this. But since we're considering from 0, so it means there will be, this point will not exist. We're just going to be having something like this. So this is this. So what we have is, yeah, going to look like this. Beautiful. Then the next one, what I've just drawn right now is s squared over 4. So that this is s squared over 4. And the next one is just 4. So it's just going to be a straight line. Y is equal to 4. It's just going to be a straight line. Just a straight line down to 6. And then when it's at 0, that's just a line here. Ideally, all of these were not supposed to be connected. But let's just put that, since when it comes to expressions on Fourier, We kind of have that. Okay, so this is what our graph will look like. And yep, with this, that's the last one that I have here. So the problem I wanted to do before, I kind of think I've sketched it before. Yeah, let me see. F of x equal 3x minus s squared from 0 less than x. I think I should just say less than